Hi everybody. So I'm really sorry that I'm not there today with you. So I'm going to try this today and use this new website that makes these cool videos with my iPad. So today we're going to be, look at me, I'm here simplifying radicals with variables. So today in class what you learned was how to break up a radical that is not a perfect square. So right here we're looking at a radical that is not a perfect square. So you can see that root 27. And our goal, what you should have learned, is that our goal is to break it up into a product of numbers, one of them being the largest perfect square that is in that number. Not just a perfect square, the largest perfect square. And this is a nice, easy number. I hope you're recognizing that, that we can break it up using the properties of exponents into root 9 times root 3. When we do that, now we've taken the largest perfect square of it, and you know that the square root of 9 is 3, and root 3 is not a perfect square, so it has to stay in that funny looking symbol. You can call it jail if you want, and it doesn't reduce. So my answer would be 3 root rad 3. Okay, I still want you to kind of consider where that is on a number line. So let's just talk about a number line for a second. So here's our number line. We know that root 25, hold on. We know that root 25 is, right here, is the number 5. And we know that root 36 is the number 6. So regardless if it's in reduced form or in original form, we know that root 27 is somewhere about here. So it's a little bit more than 5, and it's not quite at 5.5 yet. So I'm going to guess it's approximately 5.2. And, you know, we'll be practicing that with our calculators, so we're going to make sure that that works for us. Okay, so what do we have to do today? And I'm trying to do this as clearly as I can, and this can start to get funky when I throw in variables. Okay, when I throw in variables. So let's look at our first example. Square root of 18x squared. Well, when I started teaching you guys about radicals, I said that you could always, when you have the square root of a number, okay, that the opposite of a square root was a square, raising it to the 2 power. And the opposite of something to the 2 power was a square root. So that in essence, the square root canceled out the x squared. So when we're looking at variables, that's basically what we need to do. We need to cross out every x squared, meaning every x to the 2 power, with a square root. Now there's going to be cases where they're not squared, so what are we going to do? Well, let's look at our first example, 18x squared. 18x squared. So first we have to deal with the number. The number, we know, I think you guys can recognize that the largest perfect square is in 18 is 9, so I'm going to rewrite that as the square root of 9 times the square root of 2. And I'm using my finger. I forgot my stylus, so bear with me. And then I still have this x squared. Okay? All right. Well, we know that the square root of 9 is 3. Okay? And we still have the square root of 2. Put some room right there. Well, the square root of x squared, we know that the square root cancels the square, so we're left with x. So we're going to bring that out to the front because he's kind of out of the jail. And so in simplified form, my answer is 3x root 2. Okay? All right, so that's a basic and easier example. Let's look at my next slide. All right, let's see if we can figure out a pattern. Well, the first thing that I always tell kids to do is let's think about turning each of these using the laws of exponents into a perfect square. All right, so x to the 1 power. Could I write that like that? Does that mean the same thing? It does. All right, so now if I make these all square roots, then, and I make this a square root, then this cancels the square, and so I'd be left with x to the 1, which is just plain old x. All right, now I have to do that here. Well, how do I turn x to the 4th to make it a perfect square? Well, couldn't I use the laws of exponents backwards? Now remember, we've talked about how oops, let me erase that. Don't like it like that. X squared, couldn't I write that as x squared squared? Because power raised to a power, we multiply exponents. Yes, I can do that. So then this cancels with that outer square, and I'm left with x squared. All right, let's do it again. I'm going to go to the next one, x to the 6. How can I write x to the 6 as a something raised to the 2 power? So now I have something in parentheses to the 2 power. So I have x to some number raised to the 2 power. Well, power raised to a power we multiply. So that becomes x to the 3 inside the parentheses raised to the 2 power. So now the square roots cancel, so I'm left with x to the 3. All right, do another one, x to the 8th. Okay, so I want a square root. I want something in parentheses, a variable to some power in parentheses, to the 2 power. Okay, so x to the 8th. Well, to get 8, I'd have to put a 4 there. So the radical cancels with the square, and I'm left with x to the 4th. And the reason that is because a square root means that you're looking for perfect squares. Perfect squares are two numbers that are the same multiplied twice. So you're looking for pairs of things. Now, this is kind of the long way of doing it. You might start to notice a pattern as long as all these exponents are even. How do they relate to the number 2? Well, they relate to the number 2 because you're just really taking the exponent and dividing it by 2 and left with x to the 1. 4 divided by 2, x to the 2. 6 divided by 2, x to the 3. And 8 divided by 2, x to the 4th. But notice all of the radicals are gone because we've cleared them. Okay, so hopefully you're noticing that pattern. All right, let's move on to the next slide. Okay, so basically, if the exponent is even, then divide the number by 2. Then remove the radical and keep the variable that number of times. All right, so let's try. I want you to try x square root of x to the 16th, the square root of x to the 24th, and here, let me make you this one. I made it a little harder. The square root of x to the 6th, y to the 4th, so two variables. So take a second, try those. You should be working. You're still listening to my voice. Coach Fred's still here. You can do it. Got it? Yay! Okay, so let's try. So x to the 16th, so I divided 16, it was even, it's under a radical. I divide 16 by 2, I get 8, so my answer would be x to the 8th. X to the 24th. It's even, it's under a radical, so I take 24, I divide it by 2, answer x 12. Radicals cleared. All right, now I throw in another variable, not going to be scared. X to the 6th, y to the 4th. Divide 6 by 2, get 3, x cubed. Y to the 4th, divide 4 by 2, I get y squared. And there's my answer. Okay? All right. Let's see, can we move on a little bit? All right, so going on to next page. All right, so let's look at one that's just a little bit harder. How about now I do, let's see, let me think of a nice number. 24, x to the 10th, y to the 6th, all under a radical. All right, so again, now I've thrown the number in there. I'm not going to get scared by it. 24. So I now have to simplify my radical. I'm looking for the largest perfect square in 24, and then I'm going to deal with the variables. And if you want to write them separately, go ahead. All right, so 24 can be written as the square root of 4 times the square root of 6. Square root of 4 is 2, so 2 rad 6. X to the 10th, it's an even number. I'm going to divide it by 2, and I'm going to get x to the 5th and out of the radical. And I'm going to take 6, I'm going to divide it by 2, I'm going to get y cubed. Now I got to put all of these things together. All right, so how do I do that? So my answer would be 2x to the 5th y cubed root 6. You can't take that 6 out because it's not a perfect square. So it's in its lowest form. In its lowest form, it has to be in that root. Okay. All right, well, you might be thinking, what do I do with odds? All right, so what do I do with odds? Well, odd numbers are funny. They are. They're funny. That's why we call them odd. We don't want to be odd, do we? No, we don't want to be odd. We don't want people to think we're odd. So we have to do something different so that they don't look so funny. Look at a basic example. X to the 5th power. Well, there's lots of ways to do this, but what I do is I like to make it so it's written as a product of two, one being the highest even, and so I can make it an even power. And then I'll have 1 left over. So I rewrite it as x to the 4th times x. I use those properties of exponents to help me. Well, x to the 4th times x is the same as x to the 5th, isn't it? All right. Well, then I'm going to rewrite it one more time. I'm going to write x to the 4th times the square root of x because I can use the properties of exponents to do that. Then I know that x to the 4th is an even power. I divide it by 2 and I get 2. So my answer then is x squared. And I'm left with a root x. Okay? All right, let me do another one. Oops, sorry. Next page. All right. And let me switch to that color, and I'm going to do x to the 13th, y to the 6th. All right. All right, so first I'm going to deal with that y to the 6th because it's even, and I love to deal with the even. So I'm going to divide 6 by 2, and I'm going to get 3. So I've got y cubed, and I'm going to pull it all the way out to the front because he's gone from the radical, and I've taken care of him. Now I've got to deal with the x to the 13th. All right, so I don't like odd numbers, so I'm going to split it up to make it an even and 1. So I make it x to the 12th times x. I've now made it even. I take the 12, I divide it by 2, and I'm going to get x to the 6th. So I have y cubed, x to the 6th, and that's leftover x is going to stay in the radical. So if it's an odd number, you're going to always have a leftover inside the radical bar. So in jail. Okay, so I'm going to stop there. I'm hoping that this will help you at least get started. But if you don't, if it gets confusing for you, make sure you read the section in the book, try some of the problems, use hot math, and at that point, we're going to practice more and I'm going to answer questions on Monday. So I hope this worked out. You liked the video this way. I'm sorry I wasn't there in person, but I am smiling, am thinking about you guys, and hoping that you're having a wonderful Friday. And enjoy your weekend. Bye.